Hi, class is 17.3, and there's not really new material. We're just doing real life problems, and we're also kind of taking one more step and adding on to that from what we did in 17.2, well, for at least for some of the problems. So here's the first problem is as a part of a research project, the blood pressure of 1,500 patients in a hospital are recorded. This is systolic blood pressures given in millimeters have an approximately normal distribution with mean 125 and standard deviation of 13. So let's go ahead and draw that picture. Maybe I can draw it up here. Well, draw a bell curve, and in the middle, right in the middle, is our 125. Now, because the standard deviation is 13, I'm just going to go ahead and fill in one standard deviation above and below the mean and just fill in a bunch of them because I know we're probably going to be using that. So 125 plus 13 with plus one standard deviation, which is 13, is 138. If I add 13 to that, it's 151. If I add 13 to that, it's 164. So this is the mean in the middle. This is the mean plus one standard deviation. This is plus two standard deviations. This is plus three standard deviations. And there we go. Okay, and then on the other side, we can do the same thing. We can start with 125 and we can subtract 13 to find one standard deviation below the mean. And then I subtract 13 again. And one more time. Oh, 86. What I was thinking. And so, like I said, we can fill that in and just remind ourselves that this is one standard deviation below the mean, two standard deviations below the mean, three standard deviations below the mean. And there we go. That's our picture. Okay, so they say in the first question, estimate the number of patients whose blood, and they want the number, not the percentage, the actual number, which means we can, problems from the previous section, we would find the percent of patients between 99 and 151. Maybe we did that previously, but now they want us to take one more step. Once we find the percent, we're going to take that percent of 1,500 to find the actual answer. So first of all, we need to find the percent of the population between 99 and 151. So here's 99 and here's 151. So let me draw it on here. There's 99 and 151. So that's all of this area in here. Okay. We first need to know what percent of the data is in that area. Well, notice how 99 is two standard deviations below and 151 is 2 standard deviations above. So really we need to know how much data is within 2 standard deviations. And we come back here to this picture, and I have it all. So really we want to know how much is between 1 standard deviation below all the way up to 2 standard deviations above. That's what we really want to know. And we can see that is known. They show us, this line right here shows us that 95% of the data will be within these regions negative 2 standard deviations above the mean and positive 2 standard deviations above the mean. So we know this answer is 95. So that's 95% of data. And let me just erase everything on our picture so that okay. So we need to find out, that's 95% of the data will be between 99 and 159. So we need to find out what 95% of 1,500 is. So to do that, we turn this percent to 100, to the decimal. So by moving it 2 places to the left, so that's 0.95, and I added a 0 in front. The multiplication dot reminds us that we need to, the O and the of reminds us that we need to multiply. So that's times 1500. So that's equal to 1,425 people are about, there's 1,425 people who have a blood pressure between 99 and 151. All right, let's go on to part 2. So all of these are going to be very similar. First, we're going to have to find out how much area is underneath, or how much percent of the data is between the 2 given cutoffs. So estimate the number of patients whose blood pressure is between 112 and 151. So here's 112 and here's 151. So they're trying to figure out how much data is in here. Right? So first of all, I notice that this region right here, if we look back, that's between 1 standard deviation below the mean and 1 standard deviation above the mean. So I know what that area is. It's already 68%. And we can see that's from this rule, they show us that, right, between 1 standard deviation below the mean and 1 standard deviation above the mean, 68% of the data. So we see that. So I know that, okay, so that this area in the middle is 68%, but what we need to do is we don't really need, well, we need that area, but we need the whole area. That's what we need. But I do know that this part is 68%. So if I can just figure out what this part is, then I can add those 2 together, and then I'll know the area, the total area. So that's what I'm doing right now. So just show you that this part, that is 68%. Right? So now I have to find out what that part is, and then I can add them together to find the total green region. So the question is, how do I find that part? That is the distance between the 1 standard deviation above the mean and 2 standard deviations above the mean. Well, I do know how much area and is between within 2 standard deviations of the mean, or what the percentage of the data is between 2 standard deviations of the mean. So let me show you. I know this amount of area. That is 95% of the data is between 2 standard deviations above the mean. as we saw actually from the previous problem, right? Yeah. So from the previous problem, we know that, that's 95% of the data. But now we're really from the previous problem, they're chopping off and they're saying, but we don't want this area that's between -2 and -1. So how do I find that amount of area? What I can do is I know that this inner region, this area within one standard deviation of the mean is 68%. And the whole area from -2 to +2 standard deviations of the mean is 95%. So I can take away the 95 or take away the 68 from the 95. So we can do 95 minus 68, and that is 27. So that's telling me that there's 27 in this area and this area, because the whole area was 95% of the data. And then I took away the red area because I'm trying to figure out how much is it really in here, or how much is in here, however you want to think about it. So I think above, I was trying to figure out how much is in here, but they're the same thing because these are symmetrical. So it doesn't really matter. But I will say that there's 27% of the data is within both of them, and they're the same size. So if we take that and divide by 2, I'll know how much is on this side. And the same amount will be on that side. So I can take 27 divided by 2, and that's 13.5. And that's telling me that in this region between 1 standard deviation above the mean and 2 standard deviations below the mean, there's 13.5% of the data. So how much total? We just add them together. 13.5 plus 68. Oh, plus, that's hello. Be very careful. So 68 plus 13.5. We can always add a 0 and after the decimal place there. 81.5. Wait, so that is the percent. They're asking for the number of patients. So we finally found out the percent of data of the green region. Now we need to figure out what is 81.5% of 1,500, because to get the actual number of people, because we have the percent of people now in that region, but we want the actual number of people. So I get that, I'm gonna move the decimal twice to the left, 0.0815 times by 1500, and that gives me 222.5. Technically, they're asking us for a number of people. It wouldn't make really sense to give them an answer of a decimal answer here, because you can't have like 0.5 of a person. So you could like round, I suppose, or I don't know how the homework is going to do it. I don't know if they're going to just accept the decimal answer, or if they're going to want you to have a whole number. They probably just are directly saying what you should do in the directions of that particular problem. But I'm just going to say I'm going to round it to approximately 1,223. Can I say estimate the number of patients whose blood pressure is between 99 or higher? Sorry, I'm trying to back up and get the picture again. Sorry, give me a minute here. In slow-mo backwards. There we go. I wanted a clear picture on the top there. Okay, so now we have it. I already wrote down the answers for part B. It was 1, 2, 2, 3. Okay. Then for part C, the number of patients who are 99 or higher. So the area that we want to find is 99 or higher. So it's all of this area. So I notice 99 is 2 standard deviations below the mean. So I can see that this area, between 2 and -2, that's going to be 95% of the data. And then it also includes this tail here. So how do we find the area of that tail? So we need to figure out how, well, actually there's, as you can see, there's a tail on the other side the same size. So you have this tail right here that's outside of 2 standard deviations, and there's this tail right here outside of 2 standard deviations. So what I can do is I can take 100% all of the area underneath the curve and then take away this part, the 95%, and that'll give me what's in these 2 tails, and then I'll just divide it by 2 because they're symmetrical. There's the same area on both sides. So that's what I do. I take 100%, I minus 45%. I'm sorry, 100% minus 95%. That's 5%. So that means 5% is in these tails. So I need to know how much is in this tail so that I can take the 95% here and add it to this one. So I take 5% and divide by 2. And that gives me 2.5. So that means I have the 95%, that pink area, and the 2.5%. If I add those together, I will have the total percentage of all those greater than 99. Making sure to line up my decimals. That's 97.5. So that's 97.5. And now we have to figure out what is 97.5 of 500. Oh, of 1,500, sorry. So I move the decimal twice to the left. Times by 1,500. And I get 1,462.5. Like, again, it doesn't make sense to me to put a decimal here. So I'm going to round it up to 63. So 1,463, about approximately. Patients who have blood pressure bigger than 99. Okay. Then the next one says, estimate the number of patients whose blood pressure was between 99 and 138. I'm just going to draw my thing again. '99 was 2 standard deviations below the mean. And 138 is 1 standard deviation above the mean. So we need to know how much of the data is in this region. Between 99 and 138. So in this region, that's just the area between that within 1 standard deviation of the mean, which is 68%. So that is 68%. So we just have to find out how much area is between 2 standard deviations, that's 99, was 2 standard deviations below the mean, and 1 standard deviation below the mean, which is the same amount of area that was between 1 standard deviation above the mean and 2 standard deviations above the mean, which I believe we found earlier. I believe we found in part B, and I erased it, but that there was 13.5, but I can calculate that again. So what I'm going to do is I'm going to find out how much data is within 2 standard deviations. So that is this region, this area. And I'm going to subtract the 68, and that's going to, and then I'm going to divide it by 2 because there's 2 regions on the side. So I'm doing 95 minus 68, which is 27, then divided by 2 is 13.5. So right here in this region is 13.5. So it's 68 plus 13.5 again, which is the same answer that we got in part B. So 68 plus 13.5. So it's 81.5% of the data is in that region. Now we need to just find out what is 81.5% of 1,500, which is the same question, which is, we already did the math for that above, because this one was 81.5% of the data as well. So it's 0.815 times by 1,500, which is the same answer, 1223. All right. So that is that is the problem right here. And so I'm going to do another video later on another example if you'd like to see it. And I'm also going to do these percentiles in another video. So let me know if you have any questions. Have a great day. Bye.